Mitchell, what is this?
This is a linear bond pair.
Ooh.
It's called a linear bond pair because it is in a straight line and forms a 180-degree angle between the bond pairs. You notice that there are 0 lone pairs of electrons, and the only 2 pairs of electrons are bonded. This fine configuration here does not have a dipole because the negative charged electrons are offset by the positively charged nucleus at the center.
And now back to chemistry.
Mitch, what's this?
This is a trigonal planar model of a molecule. It has 3 bonded pairs and 0 lone pairs of electrons. They're 120 degrees apart because they are all on the same plane. And in a circle, there are 360 degrees. And since there are 3 of them and they try to get as far away as possible, they are 120 degrees apart. They call this one the trigonal planar because all the bonded electrons are on the same plane. It is nonpolar because the center of the charges of the electrons is offset by the positive nucleus.
And now back to chemistry.
Oh, wait, where'd you find this?
Oh, Joris gave it to me.
Yeah, hey, oh.
Alright, well, what do you want to know about it?
Well, for starters, what is it?
Well, this happens to be a special type of molecule.
I shouldn't have given it up.
It's a special
We're
type
not
of
giving it
molecule
back.
because there are 4 bonded pairs of electrons, which is one more than a trigonal planar molecule.
Trippy.
Now they are on a 3D plane, so that increases the space that they are away from each other. It happens that the angle between each bond is 109.5 degrees.
Oh, wow.
Cool.
And this molecule is also nonpolar because the center of the negative charge of the electrons meets at the positive center of the nucleus. It is called a tetrahedral model because the 4 bonded molecules combined together make a tetrahedron.
We good?
Yeah, we're good. We're rolling. Yeah! And now back to chemistry.
This tetrahedral pyramidal molecule, it consists of 3 bonded electrons, 1 unbonded electron. The angles between the molecules are less than 109.5 degrees. And the one unbonded electron up here has a stronger charge, which pushes down on the bonded electrons, and that is why they are kind of below the plane here. And this molecule is polar because the center of the charges is not at the nucleus, it's down here. It is called tetrahedral pyramidal because there are 4 electrons, and the 3 bonded electrons create a pyramid with the nucleus.
And now back to chemistry.
Hey Evan, what's this?
This is a tetrahedral bent molecule. Consists of 2 bonded pairs of electrons and 2 unbonded pairs. The bond angle between the bonded pairs is way less than 109.5 degrees because of the 2 unbonded pairs of electrons on top. This molecule is polar because the positive charged atoms and the negative charged electrons do not meet in the same spot. The positive ones would meet right in the middle, and the negative charges would meet at the nucleus.
It is called tetrahedral bent because there are 4 total electrons, and the 2 bonded electrons create a bent shape with the nucleus.
Okay, right there is good, Joris. Oh, crap! And now back to chemistry.
This is a
Hey, Joris, what's this?
Well, Wilson, what you've got there is known as a trigonal bipyramid molecule. It has 5 bonded pairs of electrons, and as you can see, there are
2 atoms at the north and south pole, and 3 atoms around the equator.
Equator, there is a 120-degree bond angle.
Cool.
And between the poles in the equator, it is 90 degrees. It's nonpolar because the charges meet at the center and cancel each other out. Also, you can't draw a line between them. They are in the shape because this way the electrons are as far away as possible.
This molecule is called a trigonal bipyramid because there are 3 molecules around the equator, and it forms 2 pyramids, one on the top and one on the bottom.
Why, George? Why? And now back to chemistry.
Hey Mitchell, what's this?
Well, this just happens to be a type of molecule called the seesaw molecule. It is called the seesaw molecule because it kind of looks like a seesaw. Kind of.
Sounds scientific.
Oh, look at that shot.
Wow! That's
Well,
quite the seesaw.
You'll see that the seesaw molecule consists of 4 bonded pairs of electrons with 1 unbonded electron at the top here. The 1 unbonded pair of electrons is up here alone pushing down on the others because it has a stronger charge than the other 4. The bond angle between these is less than 120 from here to here and less than 90 from here to here.
Thank you.
It is less than 90 because of the force of this unbonded electron pushing down on the others. This molecule is polar because the center of the charges is down below the nucleus, so the positive nucleus and the negative electrons do not cancel out, creating a pole.
What's this one?
This is what's called the T-shaped molecule.
Oh,
This consists of 3 bonded pairs of electrons and 2 unbonded pairs of electrons. The bond angles between the bonded pairs are 90 degrees and 180 degrees. This is a polar molecule because the center of the positive charges does not meet in the same spot as the negative charges.
But wait, Evan, why does it have its shape?
because of these unbonded pairs of electrons? I'm assuming yes.
It is called trigonal T-shaped because the 3 bonded electrons form a T-shape when connected to the nucleus.
Why'd you have to do it, George? Why did you have to do it? Now back to chemistry.
What's this, Mitch?
Oh, wow, where'd you find that?
Found it right here on the ground.
Alright, well this one just happens to be a linear molecule. It is called a linear molecule because there are 2 bonded pairs of electrons, and it forms the shape of a line. The linear molecule consists of 2 bonded pairs of electrons and 3 unbonded pairs of electrons. The bond angle between the bonded pairs of electrons is 180 degrees.
180.
And this molecule is nonpolar because the charges of the bonded electrons meet at the center at the nucleus. So the positive charge from the nucleus is cancelled out from the negative, cancels out the negative charges from the center. This is an octahedral molecule. It consists of 6 bonded pairs of electrons, all equally repelling each other, to create a bond angle of 90 degrees. The reason it's called an octahedral is because if you connected all the lines here, it would make an octahedron. This molecule is nonpolar because the negatively charged electrons each have a charge, and the center of each of those charges is at the positive nucleus, creating no pole, creating a nonpolar molecule.
Hey Wilson, have you seen Jarsh around? Oh, he's behind the car. Oh really? There. And now back to chemistry.
This is a square pyramid molecule. The angles between the bonded electrons are less than 90 degrees. It has 6 bonded electrons and 1 unbonded electron, which pushes down on the other electrons because of its strong negative force. It is called a square pyramid molecule because the molecules down here form a pyramid with a square base. You can kind of see. Yep, sorry. The electrons on the bottom of the bonded electrons form a pyramid with a square base on the bottom. This is a polar molecule because the center of the charges of the electrons is down here, and the polar molecule because the center of the charges is not at the nucleus.
That's weird, dude. I thought George was here. Oh, he's someplace else. And now back to chemistry.
Hey, JC.
This is a square planar molecule. It is made up of 4 bonded pairs of electrons, 2 unbonded pairs of electrons, with bond angles of 90 degrees between each of the bonded electrons. It is called a square planar molecule because the 4 bonded pairs of electrons make a plane. This is a nonpolar molecule because the center of the charges of the negative electrons is at the positive nucleus, creating no charge.